What's up, YouTube? My name is Johnny Bannon with Intrepid Technologies, and today is part 2 of our OSPF video series. Click that link below to follow Intrepid Technologies' Confluence How-To page, and let's get started. Alright guys, so if we click that link below, we get to our Confluence How-To page here. So if you go to Ospf, and Ospf multi-area configuration, this is the how-to I'll be doing today. So in this one, we're going to configure and verify multi-area Ospf. And as we learned from our last video, we know that all Ospf areas must be connected to the backbone area. That is to say that LSAs, right, must reach and be continuous throughout the entire network, okay? And I say this now because the next video we're actually going to learn about how an area doesn't have to be directly connected, but the backbone area thinks it's directly connected using a technology called virtual links. But today, we're just focusing on multi-area. So in a multi-area configuration, what we have is routers that are in the backbone area. Then we have a separate area, maybe area 1, 2, 3, or whatever number, right, for different routers. Real world, some network engineers do this for regions. Some it just happens, they fall into a network and this company has acquired so many other companies that the previous network engineer built a lot of different areas for every maybe integrated service router, every small shopping strip mall. There's a lot of different cases, right? So essentially what happens when a multi-area configuration is that the router that's connected to area 0 and to the non-backbone area becomes what we call an ABR, an area border router. And this term is very important in OSPF because there's only 2 other types of routers other than just regular OSPF routers, and one of those is the area border router. So once a router actually becomes the ABR from us configuring it, it's going to create type 3 LSAs, the network summary LSAs. So as we know, only type 1 and type 2 get sent within the backbone area, but type 3 is what gets created in the non-backbone area to get sent to the backbone area to tell it about its routes. So to make a little bit more sense of what I'm saying here, let me open this up. So essentially, let's say we have area 0 here, right? Area 0. And then we have area 10 right here. So the ABR in this case is R8, with one interface going to the backbone area and one interface going to the non-backbone area. So in this non-backbone area, R8 and R5 are going to flood each other with LSAs. And they're going to know about all the routes between or in area 10. R8 is also going to know about all the routes in area 0. So what R8 does is create a type 3 LSA that it's going to flood to the non-backbone area to tell into the backbone area to tell these backbone area routers about the routes in area 10. So when we jump onto R8 and we do a show IP OSPF database, we're going to see that this is creating the type 3s, okay? And then you're also going to see those type 3s in all the databases because, as we know, for OSPF to work, we need, this is still on, hold on 1 second. If we know for OSPF to work, we need all the OSPF databases to be the same. So with that being said, guys, now that we know how an area border router works, right, by creating these type 3 LSAs, let's do some configuration. Another thing to note here, sorry, I was just reading this, that these routes, right, when the area border router floods the type 3 LSAs into area 0, the backbone area, they're going to show up as inter-area routes. And this is what's going to show up in the routing table. It's going to be IA and then an O. So you know that that route came from a non-backbone area. All right. So we're just going to be using R5, R8, and R10. As you know, guys, I use this repository to baseline all my routers. So if you didn't catch my previous videos, again, I go to GitLab. The link should be in the description below. I have a project called CCIE_enterprise. I clone this repo, and that's how I get all my router base configs for all the routers in my GNS3 topology. Okay. So now let's bring up GNS3. Using Ubuntu, so we use a terminal, right? Because we're super high speed. Let's open it up. Start these devices. So the first thing I'm going to do, which I forgot to do in my last video, guys, is I'm going to baseline all three of the routers we're using, okay? And I do this so that we can just have a clean slate. And I use the term baseline to say get rid of old routing processing, right? So my baseline should just have my housekeeping commands, right? We're talking no IP domain lookup, my username and password login, and then the IP addresses for my interfaces. That's what I consider a baseline for a router, right? During labs. In production network, a baseline would be, hey, this is the configuration that gets my router up and running to work for my customers, right? And here I'm using the term baseline to get our routers ready to be configured in a lab environment, okay? So I'm going to bring this Confluence page to the side here so I can follow along. So first thing, right, baseline. So I'm going to start in R5. As we can see here, I got a lot going on if I do show IP route, ERGRP and OSPF. So I'm going to run an applet baseline with an alias baseline. This is going to get rid of any routing process I have. Wow, so much. So now if I do show IP route, nothing. If I do show IP interface brief, also nothing. So now I'm going to run another applet called interfaces, and this is going to put my IP addressing back up. And then what you see here is multicast, because I run PIM sparse mode in my lab, so don't worry about that. We're going to do the same thing on R8. Baseline and interfaces. Ignore all the stuff about multicast, guys. Interfaces. All right. Now let's follow my lab. Or my how-to, excuse me. So the first thing we're going to do is on R5, we're going to configure OSPF area 0 under the routing process. So it looks like R5 and R8 are going to be part of the backbone. Then R8 and R10 are going to be the non-backbone. And R8 is going to be our area border router. So on R5, I'm going to configure OSPF under the routing process. So router OSPF process ID, which is local, right? We're going to hard set our router ID, so it makes sense to us. We use a 32-bit address for the router ID, guys. Now we're going to do our network statements. So all active networks that fall into this prefix link that we just gave are going to be advertised with area 0. So this is going to hit all the networks in our lab. Now we're going to move on to R8, and we're going to configure OSPF under the interface process. So now we won't be able to actually hard code our router ID. So R8's router ID is going to be the highest loopback address. So right now what I'm doing is actually making this router, R8, the area border router. And there's really no special command. Essentially you're just saying, hey, this router is connected to two different networks, or areas, excuse me. Area 0 and whatever you choose to be the non-backbone area. So all these are going to be in our backbone area. Area 0, we should see neighborship come up. And the connection between R8 and R10 is going to be in the non-backbone area. And we're just going to pick random number, IP OSPF 1. And as you can see, it can be this many area IDs. So we're just going to do area 10. R10. We're going to configure Ospf under the routing process, set the router ID 10.10.10.10, do our networks, area 10. So now we're actually just putting this router just in the non-backbone area. And we do that by just using the area ID. Let's make sure everything's working correctly. So we should see some neighborship come up, show IP interface brief. Do the same over here, show IP interface brief, we'll do include up. Okay, we should be able to ping router 10. The reason we might not see the neighborship coming up is because sometimes in this GNS3 network, it just takes Ospf a while. So if we do show IP Ospf neighbor, we can see it's an X start, so it's still doing the exchanges, right? And now we can see full neighborship. Sometimes it takes a while, guys. No worries. So now we have our area border router. So now let's do some show commands. So we just did show IP Ospf neighbor. So this is going to show us that we're the designated router for area 0, and we're actually the backup designated router for area 10. Okay? So just from this alone, we could see that we're probably in different areas. Because if we were just in one area, we would either be the DR or the BDR. We wouldn't have both. Okay? So now if we do show IP Ospf database, we're actually going to see our type 3 LSAs here. So the reason you see every single route right now is because all these other routers are actually running Ospf. So when this topology first came up, right, it was running Ospf. So now the Ospf database, let's see, I don't know if we can clear the database. But anyways, that database kept all that information of all the previous routes. So it won't act, doesn't mean it will show up in the routing table because none of these are active in our network now. But we're still going to create type 3s for them to actually be sent to R10 if they do become active again, okay? So there we can see our type 3s are created. And if we go over to Miami, we know the basic rule of Ospf is that our databases have to match, right? So we're also going to see those type 3 LSAs. But we're just going to see the ones that R8 advertised to us, okay? So this is just from area 10. The reason you see so many right here is because this is the area border router. So it has to flood these networks to area 10, and it has to flood the networks from area 10 into area 0. All right, guys. So now let's do some other basic show commands. Show IP Ospf interface gig 00. So again, we're on R8, the ABR. We can see some just basic stuff, right? Where the designated router, where the backup designated router is, hello, dead times. Should show us what area we're in on here too. I'm just not seeing it, but that's okay. Might be up here, yep, area 10, network type, all just basic Ospf information. Now if we go to R5 and we actually look at our routing table, yeah, R5 is advertising all those different routes. It's okay. And the rest of my network is running Ospf, guys. Let's actually just go ahead and turn that off so it looks cleaner. So I'm gonna actually shut down everything but the connection to R8, gig 01. So interface range gig 00, comma gig 02, shut. We see a bunch of neighborships come down. shut down the tunnel. Well, clear IP Ospf process. Yes. So now I want the neighbors to come down. I want them to come back up. So actually you can see a clean routing table just with the network we set up. Okay. Should take a while. So R8, we're getting all the routes. We're getting a route from R5, but there we go. Now the routing table R5 is populated, and you can see all the inner area routes coming all the way from R10, and they're being advertised from R8 as type 3 LSAs. So they're going to go into the routing table as inter-area routes. Okay? So now we're going to do a Wireshark capture, guys. So I'm going to go into R8, and I'm going to shut down gig 01. This is the connection to R5, which is R8's connection to the backbone area. Let's start that capture. And what we're going to do is just look at the updates and the acknowledges between these guys. Because in my last video, we already kind of went over the whole link state database exchange, and we saw how these neighbors came up. Should come up soon with their LSAs. Okay, super quick. So let's look at an update from R8. Stop this quick. Go to our Ospf header. So this is just showing our type 1 LSAs. I want to see the type 3 LSAs. Alright, hold on quick. So we're just showing us the type 1s, but that's okay, guys. We know that the type 3s are being created. We see type 2s, and that's from R5. See something here. It's not showing us the type 3s. That's okay though, guys. It might be something I just missed. Maybe, I know the type 3s get created on the area border router. Maybe they're getting sent between R8 and R10. And maybe I was just confusing myself on how to explain it. Because what I'm thinking now is that when R8 sends its LSAs to the backbone area, it'll just send them as type 1 and 2s. But when it gets installed into the routing table, I'm assuming that it still shows up as an inner area route. Let's go into gig 00, shut, no shut, and this is between R8 and R10, the non-backbone area. See this come up. Alright, now let's look at the updates here. Once they fully converge, okay, we see our LSA acknowledge. Still just type 1s, type 2s. Maybe it's in our description here, saying, hey, we're the area border router. So here we have some type 3s in that, type 3 LSAs in that first update. So I could have just been hasty and looking at the packet capture between R8 and R5, but it looks like these type 3s are still being created on R8, advertised between R8 and R10. And I have to go back and look at documentation, right, to see what actually happens when they advertise those into the backbone area. So all right, guys. So again, thank you all for viewing. I hope you learned something. I know I did. I got to go back and look at the documentation for those LSA types. But yeah, that's the point of labbing, right? So we can learn and then take what we learn into the real world. So from everyone here at Trippet Technologies, I want to thank you guys for viewing. And remember to learn every single day.